So when you have never programmed, it can be a bit daunting to know what is good software and what is bad software, how to go about producing code. You can get functioning code okay. I mean, it might require some work, but you can get to functioning code. But how to write good code? So unfortunately, there is no recipe for this, but there can be some good practices that can help you get there. So the first one, and maybe the most important one, is that you should never consider a program as one big piece. It's actually many small pieces that have to fit together. So what you want to do is to want to break down the task that you're trying to implement, or the different tasks that you're trying to implement, and make the program as modular as possible. So you want to consider little bits and program those little bits separately, and then make it work all together. So really, start your programs by writing the headers of the functions or the titles of the functions, and then populate the bodies of those functions. Okay, so it goes hand in hand that if you're programming the subtask, you want to test the subtask as well. So you want to make sure that you can eliminate some part of the program from your head. So consider this part as done. So in order to do this, you want to program it, but then you want to perform the tests on particular subtasks. And if that part of the program passes all the tests that you have thrown at it, you can be confident that this part actually performs as required. It sort of goes in hand with the fact that you want to modularize your program, that you should try to reuse as much as possible existing work or libraries. And you will see that if you modularize your program properly, someone has probably thought of a way of doing what you want to do with a library. Now, another very important aspect that beginners often miss is that it's important to maintain readability. So what does that mean? Well, the goal is that someone else, or maybe you in a week or 2 months or 2 years, will want to look at your code. And it should be immediately obvious to them what it is that you're doing. So this actually requires some thinking at the moment of programming itself. So this requires some thinking now so that it becomes easier in the future to read the program. So what is required from you? Well, you should be explicit. Don't try to hide things away by being clever. You just want to be explicit in what you're doing so that someone else who comes along does not have to take a long time to figure it out. You want to choose the names carefully, the names of the variables. So when you program, you have a lot of flexibility to choose the name of variables. There are some constraints, but beyond that, you're free to choose them. And as soon as your program is run or compiled or whatever, those variable names actually become irrelevant. They are just a symbol for the computer. So it's really just for humans. But it's not just for humans. It's mostly for humans. You should choose the names very carefully so that they're descriptive and helpful to understand what is going on. So an example is instead of choosing, so maybe that's an obvious example, but instead of choosing a variable name r, it's much better to choose a variable name of radius. This is much more explicit in what it is that this variable is actually containing. Now, one final aspect of maintaining readability is that you want to document and comment on what you're doing. So you always have the option when you program of adding comments, and those are in some sense useless for the compiler or the computer itself. They're just for the human's benefit. So in doing this, you are describing, in adding a comment, you are describing what you're doing, and you're really doing it for another human, certainly not for the computer. So use the comments in the parts that are the most complicated to understand, and this should actually be pretty frequent. Finally, another aspect of another good practice is to avoid optimizing too early. So what you will realize is that it's better to code to make something function, and then to try to optimize if needed. So you might not even need to optimize. That's better because in general, the way you want to write code first is probably the most natural way to read it. It's the easiest way to write it, so it's the simplest way to write it so that it's easy to read afterwards. If you try to optimize your code, then it becomes much harder to read. So again, you're not just writing code for yourself. You're writing code for yourself in a week, in 2 months, in a year, or maybe for for others who will pick up your code later, or for others in your group when doing the group projects. So those are general good practices when programming in any language whatsoever. So for Python, there is this little thing called the Zen of Python that is actually trying to describe those good practices in the context of Python itself. So it's just some funny quotes if you want, but they should give you some direction on what to do. Actually, sometimes you will know that you're following one of those principles, even though it might not necessarily be helpful to find what the best way should be. So here is a few that I would like to highlight. So explicit is better than implicit. So this means never use border cases or something weird that you found out about the language. Always be explicit in what it is that you're trying to do. Simple is better than complex, obviously, but complex might be needed sometimes, and what you really want to try to avoid is being very complicated. So you might have complex code that's not complicated for that matter. So think about that. The other thing is flat is better than nested. So nested happens when you have code that sort of goes further and further to the right. So you have more and more indentation, and you have many layers of indentation, and that's nesting occurring here. So it's better to be flat, which means have few levels of indentation like this. So that's what this line is trying to do. If you have many levels of indentation, it probably means you're not programming in the best way. Now, readability counts. I've emphasized that in the previous slide. Here is one that's important actually for Python. So there should be one, and preferably only one, obvious way to do it. So this is useless as advice, but pay attention. Sometimes you will program things and you will feel that what you've done is just the perfect way to do it. And it is likely that it is actually the perfect way to do it. And this is what this little tip refers to. So sometimes they're just beautiful, easy to understand constructions that occur. And you might find some of them by yourself, or you might find some in the examples that I provide. Just pay attention to those and try to reuse them. Try to really understand what they do and try to reuse them, because they simplify things a lot when you know how they work. And finally, these little tips that tend to show that the implementation should be easy to explain. This is probably a good idea if it's easy to explain. So that was for the Zen of Python and some good practices. I understand that this is not very directive. It's not giving you very practical tips on how to program better, but it's trying to give you some awareness of the things you should pay attention to when programming.